Hi everybody, in this video, we're going to be talking about the last part of section 7-3, which has to do with minimum sample size. And we've seen this concept before in section 7-1, so if you want to, not a bad idea to review minimum sample size in the video for section 7-1. But we're going to begin by bringing our formula up here for estimating proportions. And what we're going to do is we're going to focus on the right side of the expression. We know that this term is going to be equal to our error. And what we're going to do is we're going to take our values for error, z, p, and q, and n, and our square root sign, and algebraically, we're going to manipulate all of these, rearrange things to solve for n. And when we do that, we end up with a minimum sample size formula. Now, a lot of people kind of look at this, and the first thing that strikes them is, hold on a second, why am I putting p hat and q hat in my formula? If I knew p hat and q hat, I probably wouldn't be doing a minimum sample size because I would have all the information I needed to know anyway. Now, where this could be useful is we might know that maybe 40% of BCC students are going to register full-time for the fall, but maybe that's done with a 5% error, and we need to re-estimate an interval but with a lower error, maybe 2%, and give an updated interval. So that's exactly how the formula might still be useful to us. Now, we still might say, what if I just don't know anything about p hat? What should I do then? And there's a really awesome answer to this. There's something very special that happens if we take a look at some of the formula mechanics. Let's put our formula back up on the screen, and all we're going to concentrate on is the one part right here, our product of p hat and q hat. Now we're going to go ahead and we're going to try various combinations of different numbers that we could multiply against each other for p hat and q hat. Now look what happens when we assign a value for p hat and q hat of 50%. If you look at the product is 0.25, and that coincidentally happens to be, the way the math works, the highest number you could get for a product of p hat q hat, meaning 0.25 is higher than any other number in that third column. That's really helpful to us because when we look at the formula, it means if we use those two values for p hat and q hat, and we're multiplying against z alpha over 2 times e squared, whatever the product is of those two terms, meaning the z alpha over 2 divided by e squared multiplied by p hat q hat, that resulting number is going to come out the highest when we assign the values of 0.5 for p hat and q hat. And there's a really awesome practical connection too. Think about a situation where you ask a friend, would you like to come over for supper? And your friend says, well, I'll see if I can make it. Now, right now, you might say, well, gosh, I don't know if they're going to come or not. What are the chances they're going to get here? 50-50. So in a situation where we don't know anything about p hat, we would just go ahead and do the same thing, follow our intuition, and assign a 50% probability to p hat happening, because mathematically, it also happens to be the most beneficial way to handle the situation. Now let's take this, let's put it into practice. We've got an example up here on the screen. Pause the video for a few minutes and read through it. Okay, so as I'm reading through the question, the first thing that gives it away is I noticed the word within. And from our videos in section 7-1, we found out if the question uses within, they're trying to tell you an error value. So I'm going to go ahead, I'm going to write down, I have 99% confident, and I'm going to take that 2%, make sure you write it as a decimal. I'm going to assign it as equaling the error. I happen to know that 99% confidence is also going to be equal to z alpha over 2 value of plus or minus 2.58. Now I'm going to take this, I'm going to load it into my formula, and I'm going to end up with the number 4,161. So that's telling me if I'm that medical researcher and I wish to figure out the percentage of women who are taking vitamins, I need to be 99% confident, and I cannot be off the mark by more than 2 percentage points of the true proportion. I must use a minimum sample size of 4,161.